be looking at is a little bit of theory, a little more of the project. So I do want to cover the handout on the pure virtual functions, and then I'll come to part 2 of the project. Wednesday I'll do the RTTI that finishes chapter 5, and then start off with intro to design patterns. This part I want to start now so that it gives you a little time to digest, rather than pushing it all towards the end. But this will not be on your test, the first 80 points of your test. Okay? And then next Monday we'll pretty much dedicate the entire class to parts 3 and 4 of the project. So that way you will have the whole project with you over the Thanksgiving break. Will not be due after the Thanksgiving break, but you have, depending on how we are making progress, if you're ready to do more, you can do. If you are not, then you can, but everything will be in your hand. Before I start with the lecture, the other thing I wanted to, or maybe I'll talk about it last 5 minutes, but looking at your availability for the test, there is no clear majority on anything. So I don't know how to read it. That is Friday not a good day at all to try to hold the test. So I'll send out one more email checking out. Again, if there are more than a handful of students who cannot make a Friday, then our plan is to use the Wednesday after the Thanksgiving break for your both the test 2 and the makeup exam. In which case I will probably hold a Friday class which will be optional. You don't have to be there, so we can use it to cover material in class, or I can go with how you want it. But if that is the way we are going, then remember I will be assigning the UML PowerPoint presentation as a reading assignment. Okay? Or I'll be spending very less time on it. Again, it's a non-technical part. It is not related to programming, but how you document, and so should be okay. Probably assign you that as a reading thing over the Thanksgiving break, and then have about 10 minutes of class time available after the Thanksgiving break to answer your questions. Okay, but then just so that we are on the same page, I wanted you to know that be prepared to take the both parts of the test on Wednesday when we come back after Thanksgiving. Okay, all this and more I will also communicate over the email to you so that we all have the same information and nothing is for check. So let's go ahead and look at pure virtual functions, and then I'll come to assignment part 2 of the project. I think we completed this one. Let me get this. Right, we started with our top level function method, the hierarchy, and seeing why the regular call through the pointer doesn't work. Then seeing that the problem could be solved by putting the keyword virtual. What does the keyword virtual make the system do? Virtual makes it during runtime not only check the type of the pointer, but go ahead and do a virtual table lookup. Okay, so that not only the pointer, but what object it is pointing to, and accordingly call the correct method. Okay, so there is the virtual table lookup penalty and storage penalty, and that's how polymorphism is implemented in C++. We had looked at the transaction example. We had looked at how it is called. We had looked at destructors, right, and why they are needed. And any questions on anything here? So while in inheritance, the story was more complicated about the constructors. In polymorphism, it is destructors that may have a good reason to be virtual. Constructors, on the other hand, can never be virtual. Why? They are called when objects are created and there is no flexibility at that time. The class that you use is the constructor that will be called and is the type of object that will be created. But because destruction can be through pointers like delete P or delete an array pointed to by P. Now think of it, delete an array pointed to by P. If P is a base class pointer, that array can have objects of different kinds. So therefore different destructors may be fired. So it's a kind of polymorphism at work, right? Different constructors fired because of the same code line of code. So destructors, on the other hand, could have a good reason to be virtual. Okay, so let's go to the next handout then. So in this handout, again, here we are looking at a shaped class hierarchy. So here the base class is C-shaped as a constructor. Or let's look at the data members first. The designer thought that maybe there will be child classes. There is nothing too much that I need to put it in a private section. So this designer thought it is better to give access to the data member to the child classes than give the access through set and get methods. Okay, so made it protected. Another designer might think I will put it in private and then the things happen through the methods. Again, different designers could take different approaches. Other than the constructor, it has a get area function, a get center function, a set center function, a draw function. Okay, so here you say that draw says C-shaped draw called. That's the one that we are focusing on here. But before we look at the rest of the hierarchy, again, get area, how does it find the area? Can I find the area of a shape? Yeah. What if it is an irregular shape? It's not a triangle, not a square, not a circle. How do you find the area? There are more sophisticated methods, but you can find the area. Okay. The good news is we don't have to solve that problem here right now. So don't worry about it. But the fact that does an irregular object have an area, the answer is yes. So yes, however we find it, we don't worry about it. Okay. Now let's see who are the child classes. Here is a square class describing shape to be the parent. So in addition, those x and y coordinates are supposed to be x and y coordinates of the center. Here you've added a length. So not only does the square have a center, it also has the length of the sides. So that's what is done. Again, in a real shape class, there would be some kind of drawing. Right now the draw method is like a dummy method that just says that I've been called. Here am I, right? Again, get area decides to provide its own get area, its get side length, so that you can get this thing, and that's pretty much it there. And then there is another child class to C shape, which is C circle, and that adds a radius and accordingly adds the methods, right? Here is an example of calling. Main function creates a shape class pointer, which is used to create a new circle object and calls the draw method, and then deletes the P shape. Which draw method is called? The C shape. Why? C circle is desirable, but it didn't happen. Why? There was no virtual. Okay, so we're just testing if you were sleeping or awake. Okay, So yeah, so the virtual was missing and therefore we need to fix that. And here it is. So we've gotten rid of everything, all the other code, just focusing on the part we want to focus. So assume everything is there, the x coordinate, y coordinate, length, but we've just, for the sake of brevity, it is only showing the draw. So there is virtual void draw. There is, so once C shape has declared it to be virtual, is this required in C circle? No, it's optional, but it's a good habit, because tomorrow if a class is deriving from circle, it knows. It does not need to go all the way up to C shape to check if it was virtual or not. So it's a good habit to put the virtual. And then the C circle draw implemented. And now when the same main function is called, now you will see a call to the circle draw. So when you said circle draw earlier, you were right in the sense that that is what we wanted. But the correct answer there was P shape, because the virtual keyword was not used. So in the main function, what happened before was, it looked at, when this method was called, it looked at the type of P shape. It said it's a C shape object, and it called the draw method of the C shape. When we added the keyword virtual, here we are requiring the system, it says, okay, P shape is type C shape, let me go. Then it sees the keyword virtual, it says, this is not, this is a day I have to work harder. So it goes to the V table and checks what's the object this is pointing to. And because it is pointing to a circle object, so it calls the circle draw. Here the destructor is not doing anything as such, So here we did not see a use of destructor, but again, if the destructor was related to allocating or freeing memory or any other resource, right, was doing something worthwhile that needs to be done, then there should have been destructors and they should have been virtual. Because when we say delete P shape, it depends what was created here. It could have been a circle object, a square object, or a P-shape object. And therefore, this call should appropriately call the destructor. Right now, the destructors are empty. We did not define them, but we did get destructors. They are empty. All three are empty. We don't care. Okay? So that's the story we have learned till now in chapter 5. So let's go further. Now, let's say this was a GUI application you were creating, right? Or let's not even go into programming. If I tell you right now, I say, draw a shape, what would you draw? I cannot expect any reliable, any consistent behavior, right? You will either draw your favorite shape or what came to your mind, or you might be still sitting saying that hopefully she'll tell us what shape I have to draw, right? But if I told you draw a circle, you would draw a circle. It could be big, small, tiny, whatever, but everybody would know what a circle is, or a triangle is, or a square is, right? So sometimes in a hierarchy, we come to that point where it is important that the behavior is being defined by the child classes. So if this is a GUI application, it is important that every shape, every particular shape, circle, square, rectangle, knows how to draw itself, and yet the parent doesn't know how to draw itself. It does not make sense for the parent to know how to draw itself. Okay? Bless you. When that is the case, then you say, what do I do now? You say, I think the shape example is a very good example for that matter. You say, draw a shape, does not make sense. Draw a circle makes sense. So in the shape hierarchy, one of the desirable behaviors is that every shape should know how to draw itself. And yet we are not ready to implement the method in the base class. bad solution. What is the solution? Base class implementation, empty body. And I see that a lot. Okay? But not a good solution. Why? Memory is allocated. It does not make any sense. Okay? So then you say, okay, then how do I do it? How does the language support it if that is not a good solution? So the way the language supports it is by using pure virtual functions. So all it is asking you to say is to explicitly say that I am not going to define this function. And the way you say that in C++ is by putting an equal to 0 after the function call. Okay, so here if I quickly read you through what it says when a base class declares a virtual function, it sometimes makes no sense for the base class to provide any implementation for the function. A good example of this is shown in the C-shape class. The C-shape base class cannot provide a meaningful draw function because it has no way of knowing how a particular shape should be drawn. Right? So as opposed to, remember in the transaction example we saw, there was a profit loss, a default profit loss how to calculate it, which was buying price, selling price minus buying price, right? And then the stock object had further specialized it or overridden it by adding dividend to it, and the call object was happy with how the base class had defined it. So that is one kind of situation where there is a default behavior and some classes can override as required. And here is another situation where it does not make any sense to implement it at the base class level. There is no default behavior that we can say. So that's the situation here. Thus the C-shape class should be an abstract class. Abstract classes are allowed to declare functions that are not defined in the base class. All subclasses of C-shape are expected to provide a draw member function. To force all subclasses of a class to implement a virtual function, you can declare that function as a pure virtual function by adding equal to 0 to its declaration. If a class has at least one pure virtual function, that class becomes an abstract base class and it can never be instantiated. All its subclasses must provide their implementation of the virtual function, otherwise it will cause a compiler error, not assuming that it wants the object to be created. So, two reasons to make a function pure virtual in a class. Number one, you don't have a definition, right? It doesn't make sense to, there is no default definition. In C-shape, draw. I don't know how to draw a shape, right? That's one reason. Another reason, and a very good reason at that, is if I want to make sure, ensure, or force my subclasses to have a particular behavior, okay, then that's another case where you should use a pure virtual. Okay, yes?
Can a pure, let's say we are implementing a pure virtual function, the class becomes abstract class. In that case, how can polymorphism work? So we can't create an instance of the base class.
But it can have many child classes, so the pointer can point to many kinds of objects.
Right.
One of them is not its own object, but it's still using polymorphism.
But ma'am, the base class can't initiate any of, or rather, it can't.
Okay, so we can never create a base class object, but we can create a base class pointer.
Okay, right.
Base class pointer can point to many different kind of objects which are child classes. Okay, so if, for example, if I take the example of this one only, C-shape, C-circle, what did we have? Square, right? C-square. The C-shape pointer, before it is pure virtual, could point to a C-shape object, a C-circle object, and a C-square object, right? And when the draw method was called, one of the three should have been called depending on what object it points to currently. Now that C-shape will be an abstract class, I cannot create an object of C shape. I can still create a pointer of C shape. Now the pointer of C shape can point to a C circle object or a C square object. So still there is polymorphism. When I call draw, it is one of these two draws. Tomorrow there may be 3 more child classes, triangle, rectangle, and so on and so forth. So there is a possibility of having to choose between one of these 5 draws. So still the base class pointer is calling the polymorphic method. The only difference is now it's one less object it can point to, which is an object of itself. Okay, so that's the only thing that changed.
Even if we can't create an instance of the base class given its abstract, we can still have pointers to it. Right?
Yes, yeah. So therefore that is there. What other questions should you be asking at this point? It says implementation should be provided by the child class, right? Let's say we created a class called curved shapes. And when I'm thinking of curved shapes, I'm thinking of circle and oval and so on and so forth. So, if I say draw a curved shape, can I expect consistent behavior? No. Right? It's just that I brought some kind of commonalities at that level, and instead of making circle and oval to be children of C shape, I introduced a middle level, and I want now circle, oval, and any curved surfaces to be children of this. And there is, let's say, a straight line object or straight line shapes kind of, right? So let's say now C curve decides not to implement the draw method. What will happen now? No, it exists. Okay, it has not been implemented. So remember, as I said before, always remember anything we learn is in addition to what we have learned. Okay, I'm not changing anything I told you in inheritance. So in inheritance, I told you everything gets inherited. That is still true. It will always hold true. Okay, so when I declare the curved shape class to be a child of C shape class, it inherits that pure virtual function. Now, in general, what was expected or what C shape thought was that this class would implement the draw method. But this class said, I am not ready to implement the draw method. Okay, because I don't know how to draw a curved shape right now. So what does it do? It pays the same price that its parent paid. So this class is also an abstract class. Because it did not implement the method, it has inherited the method. So it has inherited a pure virtual method that it is not implementing. So what happens? Because I have a pure virtual method, I am an abstract class. So C curved also is an abstract class. You cannot create an object of the curved shape class. Okay, so to not be an abstract class, you have to implement a pure virtual method. So either, and again, the answer, more than penalty, it's a question of what is right at that point in the hierarchy. It's not a race that an object can be created or an object cannot be created. It's about what makes sense in that hierarchy. But in terms of the inheritance, remember, so number one we are learning is that a virtual method can be pure virtual. What is pure virtual? That I am kind of postponing the implementation to my child classes. Okay? 2 reasons I do that. One, because I may not be ready to implement this method at this level. Can be one reason. And second reason, which is more important in a way, is how do I make sure that all my children implement this behavior. Otherwise, they will be abstract. So when you have to enforce this common behavior, that is the way to enforce this common behavior, is by putting a pure virtual. Now any class, any shaped class that desires to be not abstract, a regular class whose objects can be created, has to, it's like a contract, right? It has to define the draw method. Otherwise objects cannot be created, obviously. So that is a more important reason to make functions pure virtual, or a combination, yes.
For example, I have a hierarchy and somewhere down the line I choose to define the pure virtual function. And another class, maybe let's say inherits the class where I've already defined the function, pure virtual function. From that point onwards, I don't think it will remain an abstract class, will it?
After that, no. It has been defined, so it will inherit the definition. So then it has inherited a definition.
Well, in that case, I mean...
So it is, so in a way, whether, so okay, so now the question is that there is a child who has implemented this method, right? So it doesn't have it, so it's not abstract, the method, so the draw functionality is there, right? Let's say we had a C rectangle class and it did the draw. And C square can be seen as a specialized rectangle, right? We can say that square is a rectangle of equal sides, that's the only difference, right? So we can make C square as a child of C rectangle. What if it doesn't define the draw method? Now it is inheriting a defined draw method. It is not inheriting a pure virtual method. Because where do you inherit from? From your parent. Remember, for the child or for at any level, the relationship is only between child and parent. I never should think about the grandparent, what it did, where it came from. For me, my world begins at my parent, and that's where I will look for. My parent might have in turn inherited from its parent, but that is their job to tackle. As a child class, I only look at my parent class. Question?
Well, I'm inheriting the virtual method. I will have to redeclare it to be pure virtual.
So if a method has been declared virtual,
Curved shape is inheriting C shapes draw method, which is a pure virtual method. But I'm not going to implement it in curved shapes again. So I will have to redeclare it to be pure virtual.
No, you don't have to do anything. You have automatically inherited and it is pure virtual. Okay.
So can you just re-explain that curved class which you have just...
So we have a C-shaped class,
right,
that has a pure virtual method called draw, and then we create a C-curved class, C-curved shaped class that declares C-shape to be a parent. So it inherits the pure virtual method and it decided not to implement it. So then it also becomes an abstract. And then C circle might be a child of C curve and might implement it and may not and will not be an abstract.
but that one will be again a virtual.
Yeah, once virtual, it will stay virtual in the hierarchy. Pure virtual is just a way of saying I am postponing implementation to my child classes, to my descendants, whenever they think they are ready. But unless they are ready, they will be abstract classes. Okay? So here is the same code with only the draw method. Equal to 0 has been added up there as a pure virtual method. In the circle, nothing changed. In the and in the main function, nothing changed. Okay? But the only thing that cannot happen now is if I try to declare an object of type C shape, that will give error. it will say that that's not possible. C shape is an abstract class. Yes.
So can we explicitly state a class to be abstract?
No, so you don't use the keyword abstract as
No,
such.
if I want a class to be abstract, even though it might not contain a pure virtual function.
No, that's the way you make abstract.
Okay.
In Java, you have the keyword abstract. Then it's a whole different kind
Okay,
of
so
story.
you are able to do it.
Yeah.
What if we don't have any canvas, just a function declaration class?
So you have only function declaration,
And no.
only prototypes or also implementation?
Only prototypes.
Yeah, so that's the way, so that's the counterpart to create interfaces in C++. So see, in C++ we have multiple inheritance. The way Java went was, they saw the issues of multiple inheritance, saw that this, some group of programmers thought that it was too, complicated. So, lot of languages, depends on the language you are looking at, but taking Java being a popular, language. So Java went saying, we will only allow single inheritance. So then you say, how do I reuse code from, if I want to reuse code from more than one place, right? So they gave interfaces. What was interface? Interface is like a collection of functionality. The most intuitive example that I find is like if you were creating a GUI application and you wanted your application to respond toward mouse clicks, right? So you have a mouse interface. So the person who put together a mouse class, so to say, a mouse interface, right, said what? You have to tackle left click, right click, double click, click and drag, etc., etc. Right? That is what you do. When you are using different applications, does the left click always generate the same behavior? No, it depends on the application, right? If you have a drawing application, click and drag will probably get something and put there. Another application, it might draw a line. Another application, it depends on the tool you have selected, right? Within an application, it might show different behavior. But anybody who is who is enabling the use of mouse has to handle these things. So you see the commonality and yet the differences. So in Java, when you were not ready to, or it did not make sense, or you were not ready, however you look at it, to provide the functionality, they said you can create interfaces. So interfaces are a collection of functions that are not ready to be implemented. The user of this interface will supply the implementation. So if I am writing an application that uses a mouse interface, I am the person who will say that what will it do in my application when you do a left click, a right click, a click and drag, etc., etc. Okay. So in Java, you can only have single inheritance. So you have only one parent class, but you can implement as many interfaces as you want. Okay. In C++, how do I model that? Interface is an abstract class with as many pure virtual methods. That's the Java equivalent of an interface in C++. And then we use multiple inheritance. So in C++, as such, interface and class is not different. Ideas are similar. The way C++ went was to allow multiple inheritance. The way Java went was saying only single inheritance, but you can implement many interfaces. Okay? So generally speaking, C++ is more flexible. But by now I think you understand that more flexibility means more complicated or more responsibility. Then you have to handle those things. I mean, C++ gives you a lot of flexibility. You can do great, beautiful programming using C++ inheritance, given the fact that you have public, protected, private, a well-designed hierarchy has a lot of things you can use, right? At the end of the day, you have 3 different kinds of inheritance, public, private, protected, using one or more parents. Right? But then it's the same thing. You have a lot of things to play with. You better have a good plan. Otherwise, it's easy to get lost. And that's the kind of thing that Java tried to put more in structure. They both have their advantages, they both have their disadvantages. We cannot clearly say this is better or that is better. Or it appeals to one programmer, C++ will appeal more, and to another, Java would appeal more. But it is definitely more structured, more safe as opposed to C++, but less flexible. So that's the point. Nothing for or against a language, just a very objective comparison. Okay, so basically that was it here. And that's the end of your handout basically. So the only thing here is it's an easy concept comparatively. You cannot create an object. That is the penalty you are paying for being abstract. Okay, pointers can still be created. Okay, with that, let us go through our part 2 of the project. Okay, so in part 2 of the project, in part 1 of the project, you could create a dice. That's it. Right? So the dice could have different dice faces. You were picking out from a pool of 8 times 8 dice faces and creating a dice with 6 faces. Did it have to have 6 different faces? No. There could be same faces. Fine, right? So you had a pool of 8, so you are picking out of 8 different boxes. Whichever you picked was defined, could have been random, and those of you who were ready, I had put the input file that you could use, right? Whether you used or not was not a requirement. Now it will be a requirement that you will use the input file. So what are we doing essentially in part 2? At the end of part 2, now you can play the game. Okay? What you are creating here are 4 classes that I am suggesting. If you are creating 1 or 2 more because you feel that is a better design, go for it. But if you are thinking I want to create 10 extra classes, then talk to one of us before you do it. Because I don't see any reason for you to create 10 classes. Okay? All of our designs can be different. This suggests a design that you might want to go forward with or may not. Okay, so in this part you will develop the components that are needed to simulate one instance of the game. These would include the players to be developed. So we will have now a player class, because to play a game we need some players, right? And the game materials. Now here the dice faces are kind of created. Bowl, the mice themselves, I leave it as optional. They are very simple things. You might decide they will be data members in the game class. You might decide some people like to create a class called mice and give it whatever attribute you want to. Others say I won't create it, right? I have seen solutions where I have worked with students who were very particular. So for example, in this context, again, the data members should be a bowl object, an array of mice objects, and a dice array of dice objects. They just had to see those terms there, and then whether the class had 1 member or whatever. Others say, you know what, I'm just going to use a simple integer or something, or an array of integers to store these things. Whatever you decide is fine. So those parts will be optional. So that is why we are saying that the game materials are at least partially developed. They are all housed in the game class. So now you are thinking of the game class. What does the game consist of? It has some players. It has the dice, the mice, the bowl. And we are ready to Okay, so that's your game class. Again, that's something you will be developing here. While the dice space hierarchy was developed in part 1, you could add attributes of behavior as needed while working on this part. So you did not think of adding then, but you say this I want to be handled in the dice phase. You are allowed to change your part 1. Okay, so it's an evolving project. It's not what you are done is done in stone. Same will apply when we go to part 3 and 4. If you have a good reason to change part 1 or 2, it is your code. You have all the right to change it. Okay, just keep documenting it. That's what I would suggest. Following is the pseudocode. So I'm starting like from outside in. So I'm starting with the test code to give you the big picture, and then we'll zoom in into the rest of the classes. So the test, focusing on the test code, we had talked in class about the format of the input file that specifies the configuration of the dice. The choice of the number of players and the number of dice will be a user specified input. The given samples are meant to serve as guidelines in developing a test code for this part. So unlike your assignments where we said you do not change the code of test of the driver program that is given to you, here this is just a friendly guideline. Feel free to use your own code. You are not bound to this code at all. Okay? Some of us find it helpful to have a starting point rather than creating everything from scratch, and that's the reason it is there. Okay? So basically, if I look at the main function, we have created a game object. Okay? That game before we play, we want to get the number of players. We are setting up the game basically. I need the number of players that are going to play this game and the number of dice I am going to use in this game. Okay. So again, I could have hard coded it saying that players is 4 and the dice is 2. All I am doing is, instead of hard coding, I have made it a C in C out statement. That is what I was saying. So now it has become a variable. So now your user can say 4, now user can say 3, and you don't have to do anything extra really. But it has become flexible. Yes?
There is a typo. Set dice num of, it should be dice num.
No. That's a method.
Number
This
of
one?
dice. It's reading to dice num variable.
Yes.
Setting the player.
Here, this should be dice.
Same thing next.
Yeah, copy and paste problem, right? Yes, I will correct it. Good. Good set of eyes, Kaushik, there, right? So yes, so I am reading into the number of players, setting the game, using the game objects to set the players to be this, the number of players. Again, asking for the number of dice, reading it as dice num, and setting the dice num, this should have been dice num. Okay, so I'll correct it. Again, outputting how many mice you want to start with. Again, to be in your comfort zone, if all this while you have thought of 4 players playing with 20 mice and 2 dice, give that configuration here. Okay? Actually, what I would do is, initially as you are starting to develop this, I would use the same variables, so that first you can see that your program is working right. Then play with it. Now your game is ready, now you can test it out. Okay? So yes, this should be dice num and this should be mice num. So at the end here, the game object, so you can guess from here, the game object will have the attributes of the number of players, the number of dice, and the mice, right? And all that has been set till now. I mean, another variation could have been, I could have asked for all these variables, all this information before, then created the game object and used the constructor to set up all this. You know, that's another very basic variation. Now we are asking, this is giving me the dice configuration. That is coming from an input file. What is the format of the input file? The first number will tell me the number of faces in the dice. Okay. The second number will tell me how many colors are there and dictates how many of the next lines will give me the information about colors. Because it says 2 colors, I expect 2 lines to get that information, the name of the color and the probability of that color. And the third number, which is 4 in that file, tells me how many symbols. Okay, so after the number of color lines, there will be so many number of symbols lines with the name of the symbol and the probability. Because those two numbers are 2 and 4, the 2 lines after that line should add, the probability should add 200, and the next 4 again the probability should add 200. Okay, that is not something you have to check. The format of the input file is like a contract between the client and the developer. You have to define, you have to agree on these formats. So same thing, I might change the file for the demo, but it will be the same format. So you will use the first line to set those things, and the second and third number will decide how many lines you will read for the color information and how many lines you will read for the symbol information. Yes.
I mean, it's fine. We can change everything other than the first line.
Yes,
Just now,
I
if
guess.
correct the
Yes.
change the first
So,
line.
and also on, yes, you can. And also on that note, just to be clear, for your demos, the numbers will not go any higher than 2 and 4. Okay? Because let's say I say 3 colors. What needs to be in place? I need to add to the hierarchy. Your hierarchy right now only supports 2 colors. So if I happily add another yellow, you'll say, well, I can handle reading the input, is not a problem, but my classes are not ready, right? So therefore, know that I will use 2 and 4 as the upper limit for your demo purposes. What I could ask you as a question is, what if it was 3? What changes would you need? And maybe ask you to make some of those changes on the fly. Okay? But yes, I can give you the demo file, for example, can say 6 faces, 1 color and 5 symbols. Then that 1 color will have 100% probability. Okay? So just being clear about it, that as you are writing your code, this is the time you need to know these things. But you should not worry about what if I will not make it more, because neither are your symbols ready more than 4, nor are your more than 2 colors ready. You can handle it very easily by adding those classes, but that will need a change or adding to the code. Okay? So you are reading this file. So you are reading the name of this file, so easily on the fly you can change. This may be input, and I might have another file called, for example, finaldemo.txt. So you don't have to change anything in the code. You say, okay, no problem, running the code, give me the new name of the file. You give the new name of the file, and that is the file it should read from to create the dice. Okay, game object created, players, mice, and dice numbers set. Now dice have been created. So if there were 2 dice, 2 dice will be created. If there were 3 dice, 3 dice will be created. And how will I create this dice? What are the parameters I have to pertain to is defined in this file. So now reading from the file, I have created the dice. Okay. Now everything is ready. Now I am playing the game and then showing the results. Yes.
So you say the upper limit for colors is 2.
Yes.
Is there a situation when you get the statistic for you get the number of colors is 0?
No, I'll give color as 1.
So there's only 1.
1. For color there is 1 or 2. For symbols, similarly there is 1 to 2. Okay?
And the probability is fixed, right, Professor? Like it may go from.
Probability you don't have to worry. It is my job or the client's job to make sure that it is all adds up to 100.
So the formatting.
Like the 60 will become like 0.6 or.
Yeah, you can, that is in percentage. So you can convert it into 0.6 and
Will that
0.6.
change or like it will be like the 60 reading from the file
It will be in percentage.
by percentage?
Yeah.
Okay.
0.6 is very unlikely. 0.6 is possible if I make the other thing to be 99.4, but I probably wouldn't do that. That doesn't, okay? I will do 99 and 1 if I wanted that kind of a thing. Yes.
When we start with like, what is the first step? If we have 20 masses, do we distribute it first?
We are coming to it. Okay? So that's why I said we'll zoom in. This is the outside picture. So think of your friends are playing the game, right? And you are observing, right? So you said, okay, the game so the game set up, the game is played, who was the winner? That's all the main file is done. The big picture is that. Now your question, what really happens in the play, right? And we'll come to that right away. Any other questions? Clear on the main function? You can use it as it is, as I have given it to you. You can add to it. You can totally not use it. Say this was not good, I am going to do it this way. Suit yourself wherever you stand. Okay? As I said, just recommendations or guidelines, not a hard core requirement. So now, the question on the table is, how does the play go by, right? Will we distribute first? What will happen in the play method? So with that, let us zoom in into the game class. Actually, in the main function, we only created a game object, right? So it only makes sense to see what is happening in this game class. So in this game class, here are some attributes, here are some methods. Again, you may add to them, you may take away from them, you may come up with your own configuration. This is again just a friendly suggestion. So here one game object is meant to represent one instance of the feed the kitty game. Following can be some of the data members and methods of this class. So I on my part think there is a dice array. I have 2 dice, 1 dice, 3 dice, 4 dice, whatever number of dice I am using. So I have so many dice objects, I have so many mice objects. Okay? You might decide I don't need an array. I will just store the mice. If you don't have them as objects, you might say I'm just going to create a number. That will be the number of mice that this game has. Suit yourself, okay? Think about it, decide. And so on the same note, a player array. So I'm envisioning player objects, mice objects, and dice objects. Okay. But again, mice can easily be not an object. Then some of the methods. I need to set the players, set the dice number, set the mice number, create dice, play, and results. Pretty much the methods that we saw in the main function. No, nothing new. You might add some helper methods, you might add some new methods, whatever you want to do. But again, a starting point at least. So while the set players, set dice number, and set mice number are simple accessor methods, the create dice should use the parameter, which is the file name, to open the corresponding input file and construct the required number of dice using the specified configuration. So how many dice do I create was specified by the user and set using the set dice number. Those are some things I have not listed. So dice number should also be a attribute, for example. You might want it to be an attribute. And what will these dice look like is specified by the input file that I am reading, right? Once the dice are ready, you initialize the bowl and the dice if, sorry, this should be mice also. The bowl and the mice if and as needed. If these are objects, you need to initialize, you do that. If they are pretty much primitive data integer data members, you don't need to do anything, right? Or you should just initialize it, you don't need to call any methods. Now you are all set, right? You have your 20 mice, you have your 2 dice that are created, and you have your 4 players, that's it. Now you are ready to play the game. Yes.
So are we going to specify the number of dice in the file? The input file?
We were taking it as the user input. We were asking the user how many dice you want to play with. Okay? At this point, the game is all set to begin and the play method is called. Now, to answer your question, Kaushik, what does the play method do? Right? Now, this method should display the roll of the dice and the status of the game after each player's turn and result. And result should give the final status of the game, the winner and related information about the winner, like the number of mice this player has and other statistics. In any instance of the output, you should display the roll of the dice and use the labels of the dice faces to show the dice faces rolled. So while the create dice shows, so here is a little bit of output that is there. So when you are initializing, when you are creating the dice, right? When you are setting the dice thing. So when you create the dice, that should be the output. Dice 1 has been created with those faces. Dice 2 has been created with those faces. But in the play method, for example, again, this is suggested output. You might want, if you need something else to show, you can show that. Again, assuming 4 players, 2 dice and 20 mice, before the dice is rolled, I want to show current player who is going to roll the dice, that is player 2, who will be the next player, so I know the direction of the game. Let us just assume player 1, player 2, player 3, player 4 is how we are playing right now, is how it is going. So next player is 3, and the mice, how are they distributed right now, right? So at the beginning of the game, before the first roll of the dice, the mice would be evenly distributed. Know that in addition to the 4 players, it also shows how many in the bowl. Okay, so their bowl has 7 mice, player 1 has 4. Yeah, I was dreading this. Let's just try to make the best use of the last 6%. Player 1 has 4, player 2 has 5, player 3 has 1 and player 4 has 3 mice. Then the dice rolls. Right? So in the play, the player should roll the dice. What came up? Dice 1 showed a green sleeping cat. Dice 2 showed a red mouse. Right? Now the play phase. So there in the main program, we just said game play. But within that play, there is a couple of things happening. Right? And this will happen in a loop. What is the initial status? What was the dice roll? What play happened? What play happened? Because of dice 1, player 2 slept. Because of dice 2, bowl, a mouse came from the bowl to player 2. And how about the game direction? It changes. So who is the next player now? Player 1. Okay? How are the mice distributed now? Look there, bowl had 7. Now we took 1 from the bowl and gave it to player 2. So bowl has 6 and player 2 has 6 instead of 5. So the mice shows how many are there. Yes.
So
1 and then 2.
does the mice distribution to all the players be similar to all the players, or how?
In the beginning it will be equal. So you will have those rules, right? You could do I would simply do an integer division by that number, for example, and what is left can go in the bowl. Right? Or you can make up your rules, whatever you want. Like in the initial project description, I think there were some rules. I mean, in the actual game that we have, it has some rules. So, but you know, simple is integer division, and that's fine. Initially, bowl can be 0 also. And then you will have to have this rule. What if you had a bowl to, if you get a mouse and there was nothing in the bowl? Then nothing happens. But then output something to that effect. Okay? Yeah, right.
according to this, I see that the player class is inheriting game.
No, there is no hierarchy here.
No, because
In the game class, there will be objects of the player class. Now you are seeing association and aggregation.
because in the player class we are rolling the dice. The dice is available in the player class.
Right.
So we have to inherit.
So you will either pass it as a parameter, you will not inherit. There is no inheritance here. Okay, in part 2, no inheritance. If inheritance is coming to mind, shoot me an email. I'll try to explain you in the best or see me whichever way. But here the answer is not inheritance. There is no reason for inheritance here. If you need something from the class that is calling, it should come as a parameter.
Because the roll dice, template what is given, doesn't accept any parameters. It's just one.
No, I have not put any parameters anywhere. I'm just suggesting behavior. I didn't go into the
For the
text.
first,
So and on that note, for example, and that's a good thing for everybody to know. See, when I see they say these methods, all I am suggesting is there should be a roll dice behavior and a move behavior. It does not meet, it doesn't take any parameter or doesn't return a result. Okay? I did not go into the specifications of what are the parameters. Your choice of parameters. There is so much of variability that you can use. You should use what makes sense. Okay? So now let's focus on the player class, because the player is the one who should roll the dice. The player is one who should make the move, right? So here we are zooming in further on the player. So player, I am suggesting to throw an ID. If you feel right now you don't want, you can leave it, but later on you will need it. This might be a good place to giving it, if it is player 1, give it an ID of player 1, player 2. However, up to you how you decide it, but so that we know which player, right? And then it should have, if you created mouse to be an object, then it will have an array of mice. If you decided it will just be a number that I will keep a counter, that I will increment and decrement, you will have that's why it says optional, depends on implementation. Okay? Here I am not throwing in a requirement that you have to have it as an object. It should be, a player should be able to roll the dice and move. And very good question, that roll dice. Player class doesn't have a dice. The game class had the dice. So yes, the roll dice should take the dice object as a parameter. Okay? The move would entail the actions needed depending on the roll of the dice. So you saw a sample output that is coming from this behavior. The dice itself, okay, now see the C part, sorry, this should be D again. The dice, your test program of part 1 is what is becoming the dice class now. Okay, so all that code you wrote in the test program, copy, paste, wherever it belongs. You might add, you might divide it into different chunks, but that is where it is going. So following can be some of the data members of dice class. Again, dice ID, because we can have more than one dice. Faces, dice face, pointer. That is a requirement, because that is where you will use the hierarchy from the first part. Construct the dice, roll the dice, display the dice. Okay. Before I go here, let me go this, because this gives you a bigger, the full thing. So for example, a call to create dice, that is a call to the game class object. Game class is saying create dice, would call the construct of the dice class. So what code do you write in create dice? Using the dice, call the construct method of the dice class, right, of its dice object. So if there are two, one by one, call the construct on both of them. Similarly, the play of the game class would call the roll dice of the player, because the player should roll the dice, right? But actually, who should roll the dice? The dice itself. So the roll dice function of the player class would call the role of the dice object. Whether it's so it will actually call the role on dice 1 and dice 2. So game class will call role. In that, game class will call play. In that play method, player using the player that is the current player will call the roll dice, right? And the roll dice in turn will call the roll on dice 1 and dice 2, for example. So it's a chain of calls. Okay? One is, so if you think in terms of what do you call it? The relationship, right? Game class comprises of players, dice and mice. So game is an aggregation of these things. When we say game play, right, then I call player roll dice, and then player roll dice, the dice object has to be passed as a parameter so the dice can call roll, both dice. So player and dice are associated to get the behavior. Right? It's like the university might take up an initiative to do something, right? It would call the deans, right? One of the things we are currently doing at the university level is looking at the core curriculum of the undergraduate students, right? So what happened? From the provost office, the initiative was sent to the deans, right? The deans in turn forward that email to the departments, right? And or the deans will identify people who will represent their representative schools. So what I'm trying to show you by this example is that in real life that is the way things happen. The provost's office will not do everything that is to be needed in the university, but that is the place of origination of all or a lot of actions that take place. Right? So same thing in the software. Your point of the starting point is the main function, but then everything does not have to be handled right where it was called. So in the main function we created a game class and called the game play, but the play should not have the code for everything. It may pass on that responsibility to different members in the game class. That was the aggregation. But then between those members they might associate to get the desired behavior. I'm just trying to bring in all that theoretical concepts that we had learned in the theory part or the theory lecture to your project. You are using all those strategies. Be mindful of using those strategies so that you are understanding what you are doing. Designing a good software project is as important as its implementation, or maybe more important than its implementation. At the end of the day, implementation is pure translation. As an implementation, what you are doing is you are claiming to be a master of this particular language, and you say, I will find the constructs to make this happen. But the design is super important. If it is designed well, it can be implemented in any language. Then it is the job of the expert of the language to find out what constructs. Will you use an abstract class or will you use an interface? That will depend on who the language expert is. But design is a very important concept. Okay, tomorrow you may decide, I am not really going into coding is not my expertise, design is my expertise. But remember, that's an even more important, and good design is not easy either. You have to think of a lot of things. But a good design is what will bring in all the money. So that is why it is. So that's why in the project also, as you are designing this, as you are working on this project, focus on both things, or be mindful that this is also a design experience and this is also you are learning your implementation. So you are learning inheritance and polymorphism, but you are also learning how to work with so many different entities to make them work together. Okay? So part 2, at the end of part 2, you should start playing the game. Okay? And then once the game is ready, it is fun. Because now you can change the players and the dice and everything, and it will work. Okay? So the amount of classes you are writing is less than part 1. Okay? The design is kind of laid in front of you. But on the whole, same similar amount of code you will be writing in terms of functions. Okay? Part 3 and part 4, good news, I will give you a lot of code. You are basically writing very few functions, maybe a handful of functions, but you have to think a lot there to write the code. So, going from very easy in the hierarchy, where it seemed like an overkill, to a little bit more. Here there is more code, but comparatively more thinking as compared to hierarchy to see how the logistics are working. Part 4 is basically you are putting it all together to make it work. Part 3, I will give you the header file and tell you what the implementation has to do, but those handful of methods will require a good amount of thinking. Okay, and then part 4 is basically the main code. Again, we'll give you the pseudocode and you make it run. So next class I want to finish up polymorphism, chapter 5. Start off with design pattern so that you have, we'll break the ice on design pattern. And then next Monday I want to take the whole class to go over project part 3 and part 4. Part 3 and part 4 I don't require any interim demo or submission. If you want to show us, you are more than welcome to. We are there to help, so seek help if you need to. But I think by now you are in a structure, you would have made so much of progress that I feel comfortable in letting you go and explore and do it on your own time. Basically, so from my side, next week, project is out in your code in its entirety. And then you let me know what help, etc. you need as you go forward. I, on my part, will start dedicating the whole time to design. Okay? And then we'll figure out the UML part. So I will send you an email about the, it looks like, as I said earlier in the class, there seemed to be no majority about the makeup. It seemed like not everybody is available any Friday. So I am probably going to go back to Wednesday, go a little bit longer like we did last time. So 3 to 5 kind of slot. For both the makeup and test 2, I will send one more email to ensure and seek your feedback. And then we'll see Friday, so UML will be a reading assignment. I will see if we can zero in on a Friday to have an optional class to use the class time. I'll be happy to come by, and then whoever can make it. And otherwise we will tackle it with UML as reading assignment and 5 or 10 minutes of lecture time to answer questions that you might have. Okay?